So we're going to take a look now at lesson 10.5. So lesson 10.5, when we deal with that, it's binomial theorem. That's the name of this one. But before we get to there, let's check out the bell ringer. It says, what is the sum of the infinite geometric series shown there? And so just if I were you, just kind of the process of how I would go through this information is when you got to find a sum, the first thing I would do is kind of as just by way of reminder, a sum can be calculated with the calculator using sigma, that Greek letter sigma. And so I'll mark that. It says infinite. In the last class, I told you something about that. Infinite. For the calculator, we can't type in infinity because infinity is not a real number. And so I said just to use an n value of approximately 1,000 to represent infinity. And then here's the next keyword, geometric. And so here's what I would do if I were you and I saw geometric. I would immediately go over to the formula chart and look up geometric. So this is class second period. I would go to my classwork, and on the daily, weekly links, there's the formula chart. You can click there, and you can zoom in and see the geometric one right here. There's also, if you go to Power School Learning, on the main page, on the far right, under Digital Resources, you'll see the second block has a formula chart. If you click that, it'll also open up. What's nice about this one here is I was able to make some adjustments to this formula chart. I underline the ones that are coming up as we prepare for the fall ACP. I underline the places that we might use. And not only that, I was able to make a note for you. So like for geometric, if you click on that, it'll not only show you the formula, it'll tell you that the n's correspond to one another and the ones also correspond to one another. And I gave you an example. If you had a to the 11th equals not a to 11, I'm sorry, a11 equals A2. So I'm not given the AN nor A1, but rather A11 and A2. What that would mean is your power would become 11 minus 2. So I just gave you some notes here to try to help you out. But that's the formula we're going to use right here. So I'm going to copy that over. For geometric, it's A to the N equals A1 times the power of R, or excuse me, the base of R raised to the power of N minus 1. And since we're finding a sum, we scratch out the AN equals and replace it with sigma. Whenever we do this by hand, like writing a problem with the sigma by hand, we're always going to put a 1 down at the bottom. They said infinite, so infinity should go up top, but it's not a real number. So for the calculator, we need a real number. I'm just going to put 1,000. 1,000 is big enough to represent an infinity. And the rest we just plug in across. The first term, it's right here, negative 5/4. It's negative 5 over 4. And then the R, now the R is going to be a little bit trickier. And let me close this off. By the way, when you use sigma, you never replace the N minus 1 inside the problem. The N is going to be placed on the sigma portion, not right there. That's where the calculator will substitute. For the R here, remember the formula for R is you can take any term and you divide it by the term that came before it. That was our formula from last class. So I'll use the second term and divide it by the first term. What's a little trickier on this problem is that I'm dealing with fractions. So it would be the fraction of 1/2 divided by the fraction of negative 5/4. So I'm going to get this as a decimal. It'll make it easier if I use these as decimals and then put that into the calculator over here. I know 1/2 is 0.5, so I'll go ahead and write that, 0.5. And I believe that's negative 1.25, but we'll check and then we'll type that in. So I'm going to go over to Desmos. And I'm going to first make sure my decimals were what I thought they were. So this was the second term. That's A2 right there. This was my first term. And what I was saying is the rate or the ratio is the second term divided by the first term. A2 divided by A1. And it should give me a number, which I thought it would give me a number. It's not really giving me a number. Oh, it's because I'm using the letter R. Let me delete that. It's negative 0.4. We'll learn second semester why that just happened. It's negative 0.4. That's our common ratio. So when I go to sigma, you go to functions, miscellaneous, which is the fourth tab. So first keyboard, functions, miscellaneous. You'll find sigma down at the bottom in the center. N goes from 1 to 1,000 because 1,000 is representing infinity. Our first term was negative 5/4. Our common ratio we just got was negative 0.4. And this is all raised to the power of n minus 1. Oh, you got to put a parenthesis around the power because it'll drop the 1 like that. Let me go back here. Do it that way. There we go. That's our solution. I'll go 3 decimal places. So negative 0.89. Should I leave that as a 2 or should I round it up to a 3?
Round it to a 3.
Yeah, let's go to a 3. So negative 0.893. Since I'm rounding, I'll do a squiggly line like that. Negative 0.893. That would be our solution right here. And as you can see, I didn't type the ratio in the same as I wrote it right there. I could have done it this way. It'll give us the same solution. I could have just said right here that 0.5 divided by negative 1.25. And it still would have been the same solution. So I could have just done this value divided by this value. What's tricky though, so let me erase this now, is if you try to do it all at once with a fraction divided by a fraction, like if I would have come to this common ratio, just said, oh, that's 1/2 divided by negative 5/4 and typed it in like that, notice that the formatting gets off and so it doesn't give you the correct answer. This does not match. And so it's very important that when you deal with the ratio that you get it correctly. Like when you press divide the first time, that 1/2 is on the top and then the negative 5/4 is down below. If you were going to do it this way, it kind of gets tricky though. And then it would give us the same solution. So there's number 1. That's how I would go about solving that one. Let's talk about number 2. It says a ball is dropped from a height of 5 feet and the return bounce is 60% of the previous height. How far has the ball traveled when it hits the ground for the 5th time? Round your answers to the nearest 10th of a foot. So imagine we have a ball up here and we drop it off this QR code. So it goes down, it bounces, 2 bounces, 3 bounce, 4 bounce, and then finally the 5th bounce. So we have bounce number 1, 2, 3, 4, and 5. What many students do to try to solve this problem, they say, okay, this ball dropped 5 feet. So it dropped from 5 feet here. And then the next bounce, when it hits the ground, it comes up to 60% of that height. So they just take 0.5 or 5 times 0.6, 0.6 being 60%. And this part they are doing correctly. So far, so good for many students. They do that and they get 3. So they say, okay, this ball on the second bounce reaches, or after the first bounce, reaches the height of 3 feet. And then the ball goes down, it hits the ground, and they say, okay, this one's going to be 60% of the previous height. And so they just take the 3 and they multiply by 0.6. So it's just like timesing this by 0.6 again, and then we get a value of 1.8. So far, so good. And so that's the height of this top bounce there. So we've gotten these heights. And then they do it another time and then a time after that. So this height would be 1.8 times 0.6. So I do another point times 0.6 and I get 1.08. And then the last time, let's get the last height here. You multiply it one more time times 0.6 so we get 0.648. 0.648. 0.648. So all is good so far. Here's where students mess up. Is they just say, all right, we want to know the total different distance the ball travels. So let's just add up these numbers. which on the surface looks like it would be the correct answer. But it's not, because though the ball fell 5 feet, here it went up 3 feet, and it also went down 3 feet. So it actually goes up 3 and down 3. It goes a total of 6. It doesn't just go 3, it goes up it and down it. And the same is true for every other value. It goes up and down. So each of these would actually need to be multiplied by 2 if you want the correct answer. So now if you put that in the calculator, your math would add up and work out correctly. So you would have basically 5 plus 3 times 2. Again, it's times 2 because the ball goes up 3 feet and down 3 feet. And then the next value, I believe, was 1.8. It goes up 1.8 and down 1.8. So you'd multiply it by 2. So let me just put them in parentheses so you can see. This is the first bounce. This goes into the second bounce. This would be the third. And then you would have, I think it was 0.08 times 2. That's going into the fourth bounce. And if I did this one more time, I get the 0.648 times 2. That was our last bounce right there. So I added parentheses just to show you the bounces. And this would be the solution. There's going to it travels 5 feet for the first bounce. It traveled 6 feet for the second bounce. It traveled, I guess this would be 3.6 for the third. This would be 2.16. And this one would be almost 1.4. I think that'd be like 1.396, I think, if I'm doing the math right. And you add all that up and you get this solution. So it's 18.056. This says round to the nearest tenth. So it's this. It would be roughly 18 point. If I round to the 1 decimal, tenth has a 1 0, so it'd be to the 1 decimal. Would that become a 1 or stay a 0?
Stays 1.
It actually, because this next number is a 5, it rounds up, and so it'd be 18.1 feet. That would be our solution here. Now, how could you do this using sigma? So if sigma does sums, how could I do this with sigma? Well, sigma only works if whatever's happening, the pattern is perfect all the way through it. So right now, it's not a perfect pattern where all these go up and down, up and down, up and down. The very first lead into the first bounce did not go up and down. So if I were going to use sigma, I would have to change my picture to include this portion right there, the up part of going up 5 and down 5, if I were going to solve it correctly. So what I would do is I'd have 5 bounces, but on the inside of my problem, so I'm using this formula here, I would have to change my A1 to include going up and down. So if I change that, I would have a 10 there instead of a 5. You'd say, okay, it went, we'll treat it like it goes up 5 and down 5. Now it's a perfectly matching series, so I could use the calculator. Each time it gets multiplied by 0.6 to the power of n minus 1. The only thing you now have to make an adjustment to, so this will be a lot easier way of solving this, but we have to make an adjustment to is since I came up with this extra 5 there that did not really belong, I would need to take away an extra 5 at the end. And so at the end, it's like I put it in the calculator and it gives me this full 5 parabolas or 5 little hills. I take away the 5 at the very end to take away this portion of the graph there to make it accurate again. So that's why I have a -5 at the end. So let's go over to calculator and we'll test it. We'll see if we get the same answer. I go to functions, sigma, from 1 bounce to 5 bounce. We're going to say the first one's 10, even though it really wasn't. We'll just say it was 10. N minus 1 is my power. On the outside, since I made this be a 10 instead of a 5, since I added 5 extra, I'm going to take away 5 on the outside of sigma. And notice my answers are exactly the same. So we did do it correctly. So that right there is how you could use sigma to solve this problem very fast. You just have to edit the first bounce accordingly for sigma and then take away the part that we edited at the end. Make up for that adjustment. All right, who's ready to learn how to gamble?
Me.
All right. The mathematical concept is called binomial theorem. That's why you'll see this. The reason they call it binomial is it means there's two options. And it comes in this formula here. Here's what I want you to write down to stop. This will really, to start, excuse me. This will really help you out if you think of these values in these terms that I'm about to show. The front term, the A, is the odds of winning. That's what I want you to consider. When I say A, I'm going to talk about that as being the odds of winning. Now, when you gamble, you might win. You also might, what's the other option?
Losing.
Lose. The B is the odds of losing. So again, everything in math has to be represented somehow. And I know that when many students see something like this, they get confused. How does this relate to the real world? That's what I'm trying to show you here. The A is odds of winning. B is odds of losing. N is the number of times we play. Number of times to play. So what we're going to see today is a bunch of situations, and we're going to use a equation, or that's not even an equation, that's called an expression. We'll see an expression like this, and we'll get our information from there. Or if it's a real world, we'll take the information and plug it into this expression to mathematically solve it. So that's the representation in real world. A is the winning odds, B is odds of losing, N is the number of times you play. In math, we call this the binomial theorem. All right, as a lead-in, there was a guy named Pascal who came up with a lot of this stuff. Blaise Pascal is his name, and he specifically came up with a triangle. And so when you look at this triangle, at first it looks like a random assortment of numbers. Now the row corresponds to the number of times you play a game. All right, and he based this off of 50% chance of winning and 50% chance of losing. Let me just do it. 50% win, 50% lose. Okay, now I'm about to explain what all these random numbers have to do with. The idea is this: if someone like a casino in Vegas were to expect, let's just take a game where we play one time. I'm going to flip a coin one time, and we'll see how the winners shake out. What this is saying, if it's 50-50, if two people played the game, one person wins, one person loses. That's the idea here. Okay, I'm walking you through how to understand what this big triangle means. Okay, so if we played the game once, statistically, for every one you have that wins, you have one person that loses. Do you follow so far? So I want you to think of this side as being the winning side, and this side being the losing side. Okay, so what if we played the game twice? If we played the game twice, so now we're not playing once, but we're playing twice. So I'm flipping a coin. If you're looking at my camera, I'm going to flip the coin. We'll have a winner, and I'll flip the coin again, and we'll have another winner. They start calling these things parlays in gambling is what they call it when you have multiple games going on. But let's say we play the game twice. Here's what this is saying. For every one person that you have wins both games, you'll have two people that win one and lose one, and you'll have one person who loses both games. I'm going to see if you're following the logic here. If you're going to play twice, so the first time you have some people win and some people lose, and then the second time you might have some people who won the first time win again. You might have someone who won the first time lose the second time. You could have someone who loses twice, or you might have someone who loses the first game but wins the second. What this is saying, for every one person who wins both games, you'll have two people who win one and lose one, and you would have one other person who would lose both games. I'm gonna do this one more time, and let's see if you can walk me through if you're following the logic. If we were to play the game 3 times, this row right here is saying, for every one person who wins all 3 games, so this person wins all 3. For every one person who wins all 3, what does this represent, this 3?
Win, lose, win, lose.
This 3 would represent someone winning twice and losing once. This 3 would represent someone, not someone, 3 people. For every one person who wins all 3, you'll have 3 people. Let me erase that so you can see it better. For every one person who wins all 3 games, you'll have 3 people who win twice but lose once. You'll have 3 people who win once, lose twice, and you'll have 1 person who loses every game. So it'll start to look like this. I'm going to do W's and L's here. For every one person who wins 4, I'll do it down low. Wins 4 and lose. I'm on the wrong row. We're playing 3 times. Sorry, one more time. For every one person who wins 3 times and doesn't lose, you'll have 3 people who win twice, lose once. You'll have 3 people who win once, lose twice, and you'll have 1 person who doesn't win at all, who only loses. Do you follow the concept here of what these numbers represent? Not hear anything, so let me try this. Do you see the pattern over here? What's happening to the amount of times you win?
It goes down.
Count down. So we start with always winning and we count down. What about the losses?
They go up.
Going up.
They count up. Okay, so let's say we were going to play this game 4 times. If you were going to play the game 4 times, so I'm going to flip that coin 4 times. What that is saying, for every one person who wins all 4, you'll have 4 people who will win 3 times. Let me just do W3. Win 3 times, but lose once. What would this 6 represent?
They lose 4, but no, wait, they win 4 but lose 2.
What happens is they count. So instead of winning 3, you win 2 and lose 2. You'll see that they're going to count. One counts down, the other counts up. This spot, this 4, says you'll have 4 that win once, lose 3 times, and you'd have 1 person who doesn't win at all but loses all 4 games. So that's the idea of these numbers. For every 1 person who's going to win every game, let me write that at the top. 1 person who wins 4, loses none. You have 4 people who win 3, lose 1. 6 people who win 2, lose 2. 4 people who win 1, lose 1. 1 person who wins none, loses 4. Okay, I'm looking at our class, and we have right now 23 people on the Zoom call. So let me play this out here. If we added up the total here, there are 16. 1 plus 4 is 5, plus 6 is 11, plus 4 is 15, plus 1 is 16. So right now, if I added those up, this would mean if 16 people played the game, the odds state that 1 person's always going to win, 4 people will win 3 out of the 4, 6 people will win twice, 4 people will win once, 1 person's not going to win at all out of 16 people. Now we're a little bit higher than 16, so we're going to just play this game real fast. Y'all ready? What I want you to do is I'm about to flip this coin 4 times. I want you to write it down so no one can lie. And I want you to put, whatever you think is going to happen. I'm going to say, I think I'm going to get a tails followed by heads, heads, tails, like that. That's going to be my pattern. I want you to pick that your own pattern. Write it on a piece of paper. Now I'm going to flip it. Has everybody had enough time to write down their 4 options, what they think is going to turn up?
Yes.
Yeah.
All right,
Yeah.
here we go. When I flip my first coin, I got heads. So if you chose heads, you win. I lost the first game. Flip again. I'm just going to catch it this time. Tails. If you put tails, you win. Oh no, I'm going to be the loser. I'm 0 for 2. All right, I'm going to flip it again. I got a heads. So I have a win this time. I'll flip again. Tails. I have 2 wins. So I won 2 and I lost 2. All right, let's see how our data pulled out. For the people who won all 4, how many on this Zoom call won all 4? They chose heads, tails, heads, tails.
Me.
Alex or Miguel? Or both?
Miguel.
Okay. I got 1 that said they won all 4. Maybe 2, actually. Take that back. I got Eddie on there too. I see Kevin says all 3. Okay, so we had 3 people who won all 4 games. All right, let's try. How many people won 3 times? 3 out of the 4, they got to win.
Me.
Me.
Put it in the chat for me so I can count it up accurately. Send it in the chat. So I got Gabriel, Matthew, Diamond, Josue, Melanie, Eric, and Alex. 1, 2, 3, 4, 5, 6, 7. I had 7 people that won 3 games. How many, like myself, won twice? So starting with, how many people won twice? I'll start with Jose, Christian, Xavier. Thank you, Xavier. Putting in a 2 really does help. 1, 2, 3, 4 people won twice. Oh, I forgot to include myself in there. 5 people won twice. How many people won only 1 time? Just put a 1 in the chat if you only won once. All right. I see 1, Jennifer. And then how many, Chloe makes 2. How many people did not win at all? No one wants to admit it. 12, 14, 17. I know I got 6 people that did not vote. So who knows where they are? Maybe they didn't pay attention to the whole game. Okay, so this is how our odds stuck out. If we played this over and over in a casino, you would see the numbers become more and more like this, where they would reduce to this percentage or whatever, this arrangement. Ours did not work this way. So like if we actually had 3, the odds would state that you would have a 12 there. You'd multiply this one by 6. If you had 3 there, you'd have 18 in the spot. So it would just play out like this. That's what you could expect as time goes on. Would be, excuse me, numbers would play out like this. Ours were a little bit different. In first period, when I did this, we had a smaller class. We had exactly 16 on, so it was great. But it went 1, 6, 4, 4, 1. So we were almost exactly right. It's just 2 people were flipped over there. We almost played out perfectly. So that's anyways how it works. In a nutshell, what you need to remember is this. When you see this binomial, and what I'm going to refer to all day, is A is the odds of winning. Odds of winning. What's the B represent?
Odds of losing.
There you go. And finally, what's the N?
How many times you play?
Okay. For Pascal's triangle, he called them rows. This is number of plays. All of these would be equal to N. And so though his triangle starts with the 1 on top, you never actually play 0 times. By the way, there is a mathematical way of getting all these numbers. If you're wondering, how did he get this triangle? If you look at the two numbers that are above any one number, they add up. So this 6 came from the 3 and the 3. This 21 would be 6 plus 15. It doesn't matter which you choose. That's 70. This would be an 8. If you look at any two numbers, the number that's in between them down below, it would be the summation of the two, or the addition of the two. So that's how you get the table. All right, let's start using this now. So how does this play out in real world as we go through this? Let me show you. Example 1. It says use Pascal's triangle to expand a plus b to the 6th power. So what we're saying here is we're going to play this game 6 times. I'm not going to give you odds at the start. I'm just going to leave it as math letters. So, but I will tell you, we play this game 6 times. That's the plays or row. That's how many times you play or the row you look at.
Mr. Voorhees.
Row 6. Did you have a question?
I'll just say that I have to go because I have a doctor's appointment right now.
Okay. Yeah. Take care.
All right. Bye, mister.
This is the 6th row because it has the second value of 6. And so I'm going to copy these numbers real quick. The numbers are 1, 6, 15, 20, 15, 6, 1. You'll notice that they will always kind of repeat each other. I say it's like a mirror or a parabola, you could say, is how they copy each other. It'll climb up and then it'll climb down. So those are our numbers. I'm now going to move this out of the way. I'm going to shrink it so I have room to write. So what does that mean that the odds of this playing out would be? What's weird is we don't have like a percentage to work with because it's not real world yet. It's just math. And so mathematically, here's what this means. One person, remember, this means win. This means lose, or odds of winning, odds of losing. What this means is you'd have one person who would win all 6 times. That's how many times we're playing. One person would win all 6 times, which means they would not lose at all. You don't have to put the b to the 0, but I will there. So you have one person who wins 6, does not lose. You would have 6 people who would win 5 times and lose once. So we start with best situation and go on to the worst situation. So you start with winning every game, meaning you don't lose, and then you just count down. I win 5, I lose 1. So today it's going to make a lot more sense if you can remember A means like wins, B means losing. The next set would be you'd have 15 people who would win 4 times and lose twice. You would then have 20 people who would win 3 times, lose 3 times. You would have 15 people who would now win twice and lose 4 times. Again, we're just counting down. You can see the pattern. I would then have 6 people who would win once, lose 5 times. And finally, I would have 1 person who would not win at all, but would lose 6 games. So that would be your equation. There's a few things you could simplify on there if you wanted to. Like you could write this as 1 A6 B0. You could remove the 1 and the b to the 0 and just leave it as a to the 6th. You don't have to. I'm just going to write it in real quick. And the other thing you can do is anything to a power of 1, you don't have to put the 1 there. So you could actually just write this a to the 5th b like that. And then the middle would stay the same. I'm going to try to write this in quickly. So this is one way you could simplify it what I'm doing in purple. So all these middle values stay the same. Okay, starting on this one, I'm just going to put 6ab to the 5th. You don't have to put a 1 there. It's assumed to be the first. And on the last one, you don't need to write the 1 or the a0. You could just put b to the 6th power. So those are the values that I crossed out as we went. That right there is the simplest form of our binomial. The reason they call it binomial is because there's 2 terms. You win, you lose. A and B, A and B, A and B. That's the binomial. Okay, so let's do this again. I'm going to walk you through. So I'm going to use that same Pascal's triangle, and it says to expand this. I want you to talk me through. How would we start? What would we look at first?
The row.
The row, good. So you would start with the 5th row or the number of times you play. And so you'd come here to row 5, which is right there, and you would copy the numbers, which in this case are 1, 5, 10, 10, 5, and 1. Now that I have that, I'm going to shrink this out of my way. And this problem is a little different because these aren't normal odds. Okay, this is just a mathematical problem, not really a real life problem yet. Okay, so it's kind of hard to understand, but again, I want you to think of the concept of this being the odds of winning and this term right over here being the odds of losing. Okay, that's what I want you to think of. If you can think that way, you can grasp the concept a lot quicker. What this is saying is we'll have one person who wins every game. So we're playing 5 times. Let me put that row / plays. That's how many times we play the games, 5 times. So you'll have one person who wins every game and does not lose. Again, you don't actually have to write the 0 ones. You can skip that if you want. You will have 5 people who will win 4 times and lose once, I'm sorry. So the power should always add up to 5 because that's the number of plays you have. And the front coefficients are from the triangle. Okay, so we won 5, we won 4. How many wins are you going to have next? Have you figured out the pattern?
3.
One term, I won 5, then I won 4. Now I'm going to win 3 times. Now, if we win 3 times, how many losses did that mean we had?
2.
2, that's right. Okay, now I continue on. That was that 10. I got another 10. So this time, if I won 3 there, that means I win twice on this time. And instead of losing twice, I'm going to lose 3 times. Again, the power should always equal 5 across, or however many times you play the game. After this 10 comes a 5, and so 5 times we'll have 1 win and 4 losses. And then finally, only 1 time would you have 0 wins and nothing but losses, 5 losses. The terms you can simplify out every time that you never even need to write are anything to the 0 power, the ones for the coefficients you don't need to write, and the ones for the powers you don't need to write. The rest of this you can simplify. I'm going to use a calculator. So I know x to the 5th, that's easy, but I don't know 3 to the 5th. Since that's in a parenthesis, I'm going to multiply it out. And so today what I'm going to have a lot of times is you'll see I'll put 3 to the 5th like that. And because we're dealing with numbers, sometimes I'll have like a second number raised to a power, which this is 243. If you left the 2 to the 0, anything to the 0 power is a 1, so it doesn't actually change it. So you can see how it's still 243. So this one, again, it's not, this problem is a little bit different because it's not real world. And so you would have 243 x to the 5th. What is that referring to? I don't know, but that's what it is. It's not real world because you don't say the odds of winning are 3, the odds of losing are 2. That doesn't make any sense. So here at the start, some of these won't, it's hard to follow the illustration, but this is 243 x to the 5th. Now I look at my next term. It's going to be 5 times 3 to the 4th. Now I'm going to have an x to the 4th, 2 to the 1st. So I'll go 5 in the front, 3 to the 4th power, 2 to the 1st power. So again, there's 5 total plays. 4 times we win, 1 time we lose. That's 810. This number is 810 x to the 4th. And then I go on to the next. What I'm about to type in is 10, 3 cubed, 2 squared. 10, 3 cubed, 2 squared, which is 1080. So I'd have 1080 x cubed. If you're wondering where the x's are still in there, so I gotta write those out. Then I'll do this one. 10 times 3 squared times 2 cubed. 720. Followed by this one. 5 times 3x to the first times 2 to the fourth, so a 5. 3 to the first, 2 to the fourth. I get 240. Oh, I didn't leave my x's in this one. Sorry, this should be an x squared. And then I have a 240. And this is x to the first, just x. Then finally at the end, I should just have 2 to the 5th power, which I know is 32. But let me show you in the calculator. It's going to be 1 times 3 to the 0 times 2 to the 5th. 1 times 3 to the 0, 2 to the 5th, we'll get 32. Yep. What I was saying earlier is you can scratch this out, multiply by 1. That's technically 1 as well. As you see, it's still 32. So either way, it's 32. That right there is the simplified form of the binomial. There's my binomial, or excuse me, the expanded form. That's the expanded form. Okay, so I've been trying to lay groundwork and doing it using the real world as an illustration, but then giving you mathematical problems. Later in the lesson, we're going to switch and apply this to real world, but I just have to get you to understand what each piece refers to. So this is winning 5 times, winning 4 times, winning 3 times, winning twice, winning once, not winning at all. Okay, for you, what I want you to try is not doing the whole thing. We'd run out of time this lesson. We're going to pick a value, like I'm going to look at the powers, and I think last class it was the x squared term that are different on every one of them. So like on this x to the 6th, notice that a lot of these have 64 x to the 6th. So I won't be able to get my answer finding the x to the 6th term. If you look at the x squared terms for this DOL, this is a cheating way of getting an answer really fast. The x squared terms all have different numbers. So what we're going to do is get the x squared term. First, we'll go to the row 6 on the triangle and see what numbers we should have. Okay, so let me go to this triangle. So find row 6. What are our numbers here? I want you to get them down. 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. What we're going to do is a shortcut to figure out which answer is correct is we're going to figure out which one would have an x squared. So remember the first one, do I start with winning all games or losing all games?
Winning.
So this would be my x6 term. This is x5 term. This is x4 term. x3, x2. This is the one we're going to be looking at because we need 2 wins. And so what you would be doing in the calculator is you're going to type in 15. And on this particular problem, x comes from here, which is a 2x. If we're going to have it squared, that means it's a squared there. For my other term, what you're typing in is a 3. 3 is the losing. How many losses? If you win twice, how many times did you lose?
3.
Nope. 6 games.
4.
4. Okay, you're going to type this in the calculator without the x and come up with a number. I'm going to start a poll. All right, 10 seconds. 8, 7, 6, 5, 4, 3, 2, and 1. All right, your time is up. If you would have typed this in the calculator without putting an x, you should have gotten one of these coefficients, and that would give you the correct answer. All right. Move that over. All right, so now let's move on to example 2. Oh wait, one more question on this. I chose, do y'all know why I chose the x squared term? Did I make sense out of why I chose that one?
Because they all were different.
Very good, Donovan. Because each one of those were different. If I would have said the x6th term, we might have got a 64, we might have got a 32. But either way, unless it was 32, we haven't found our answer. The x5th term, we had multiple 576s, so I didn't choose that one. X4th had multiple 2160s. And so I just went until I found one that was different all the way across, just to save time. Then over here, from our numbers, we counted down. The first number is winning every game, winning 5 games, winning 4, 3, and there it is, winning 2 times. So that's why I knew it was a 15. I got the 2 from there, the 3 from there. You put that in the calculator. 2 wins, 4 losses to get your number. Okay, so now let's do it again, but what happens if you have a negative? So previously we've been dealing with a positive. What if you have a negative? Well, only a couple things change. So first, let me see, do I still have that copied? Ah, perfect, I do. We're gonna go to the fourth row this time, because I have a 4th power. That means I play the game 4 times. So that refers to the row or the number of times you play. And so I'm looking at these numbers right here. 1, 4, 6, 4, 1. So if I were going to expand these out, you have one person who wins every game. So x to the 4th power. Again, you don't have to write the losing whenever you lose every game, or you don't have to write the winning if you lose every game. The ones that you don't win or lose, you don't have to write that portion on there, but I'll do it right there just so you see it. You'd have 4 people who would win 3 times. Whoops, I put the parenthesis in the wrong spot. It's an x, and you do it 3 times. And you would have a loss, negative 2y, only once. So you win 3 and lose 1. The next person, the next 6 people rather, would win twice and lose twice. Then you would have 4 people who would win only once and lose 3 times. And then you'd have the one person who never wins but only loses. So as I've been saying, I'll say it again. The coefficients of 1, the coefficients are the front numbers. You don't have to write. And any of the terms with a power of 0, you don't have to write that part of the term or that factor. You don't have to write those. Nor do you have to list the powers of 1. Those don't have to be there. So this problem was simplify to, there's no even numbers here, so this is easy. This is just x to the 4th plus, this would be 4x cubed times a negative 2. That's actually going to be minus. Ooh, I'll show you in the calculator. That'll be minus 8x cubed y to the 1st. X cubed y to the 1st. So I have x cubed y to the 1st power, which you don't have to write the 1. How did I get a negative 8? I'll show you. You would, on this problem, you would have a 4 out front. Since it just says x, that means a 1. We're doing this 3 times. And then it was a negative 2y, so I'll put a negative 2. And we lost 1 time. And so that's where it's negative 8. And then I'm here, term number 3. I'll type in 6, 1 squared, negative 2 squared. 6, 1 squared, negative 2 squared, which is 24. X squared, y squared. Again, the powers, the winning powers count down, the losing powers count up. And then I'll have this one, 4 times 1 to the 1st, negative 2 cubed. 4 times 1 to the 1st times negative 2 cubed, which is negative 32. Since the winning counts down, it's 1 win, 3 losses. And now the last term, plus, it's going to be 1, 1 to the 0, negative 2 to the 4. 1, 1 to the 0, negative 2 to the 4. 16. If you're wondering, well, you scratch those out. Yeah, if you don't write those in, you'll still get the same answer. So yeah, if you scratch out, you don't have to write it. It'll still give you the same answer, which in this case is a plus 16. So this is the expanded form of that binomial. Again, binomial just means it's two values, two choices, winning and losing. And this is expanded out to represent a large group of people playing the game 4 times. That's how it's represented in the real world. Now, so far I haven't given you anything real world. I've just been using mathematical, but we'll get to the real world here in a second. All right, I want you to do this one. And again, our class, we found one, was it the x squared? No, not that one. Let me see, x cubed, if that's it. Is x cubed, no, those are different. Yeah, we're gonna do the x cubed ones this time. These values, we're gonna see how these are different all the way across. So that's the ones we're gonna check. That's gonna be our shortcut. My question for you, how do you start this problem? What would you do first?
Row 6. Go to row 6.
So our row 6 is 1, 6, 15, 20, 15, 6, 1.
This whole time I've been lying and
There's our numbers all the way across. And if you want 3 wins, how many times does the first person win?
6 times.
That's right. You start with only winning and you count down. That's the value we're going to use there. And so it'll be 20 in the front. What you're doing in your calculator, you would have 20 in the front times, it's going to be a 3x here to the 3rd power, and then a negative y to the 3rd power. For the calculator, you're just going to put a 3 in this parenthesis and negative 1 in that parenthesis. Okay, I'm going to start your Zoom timer. I'll give you about a minute. Ten more seconds. And 5, 4, 3, 2, and 1. All right, time. So again, if you just would have put 20 times 3 to the 3rd times negative 1 to the 3rd, you should have got the coefficient that corresponds to this term. Now, if you honestly, you should probably do the whole problem, but I'm just giving you a little test taking strategy on how to do this, accomplish a multiple choice question quicker. And the reason I'm going faster is because I'd like to get to the real world. That's where the more fun is on this math. So now let me show you one more thing you can do if you don't have a triangle. So if you don't have Pascal's triangle, don't worry, the calculator can calculate that part using what's called a binomial theorem. And it uses this symbol NCR. Really quickly, I'm going to show you from the formula chart. Binomial theorem, you have this real long thing written out. This is what we've been working on. The shortcut for using the calculator, if you want to find just one term, is this portion right there. And so on the other, this NCR, a to the n minus r, b to the r, that part. On the other formula chart that I showed you that I have listed on Power School Learning, if you zoom in, that's highlighted. So I highlighted binomial theorem and I only highlighted this portion. And I'm going to go back in and write so you know A is odds of winning, B is odds of losing. N is the number of times you play. The R is the number of times you win, or it can be the number of times you lose. It doesn't matter what you do mathematically, it'll give you the same answer. So R refers to the actual number of wins or losses. So that's how we're going to play this out the rest of the way. So example 3, this starting here, we don't have to find the whole list. It says just find the 4th term. And so I want to walk you through this. On this game, we're playing 10 times. So n equals 10. We're going to play this 10 times, and we want to find the 4th term. So I want you to remember Then on the fourth term, and I'm going to use the term A4. On the fourth term of something, if we play 10 times, that is like saying the first term we win all 10. Oops, I meant to do a W. I want you to think of the first term we win all 10 of them. The second term we would win 9. The third term we're going to win 8. The fourth term is when we win 7. This is going to matter in a second. So the formula is going to look like this. What we put in the calculator, it's going to be NCR. You have to use a capital C in Desmos. We'll put a parentheses, and then another parentheses, and another parentheses. I call this the skeleton. This is the part you'll always just type in the calculator, and we'll fill in as we go. That's what I call the skeleton. And so what you'll put in the calculator is we'll fill in with the N, the R, the A, and the B here. The powers, it doesn't matter which one's which. Well, it doesn't matter what R is specifically. This one on the formula chart says N minus R, and this one says R. What this is the, just as a reminder, this is the number of times we play. This is the number of wins or losses. And it doesn't matter which one you choose. Mathematically, it'll give you the same. This power refers to the number of wins. This power is the number of losses. The A is the odds of winning. And the B is the odds of losing. That's a real world application, what I've just given you. Okay, we're not yet to the real world problems, but that's the makeup for it. So for this particular problem, how would we solve it? You would first write the skeleton, NCR, and then it's 3 parentheses. The first one has a comma, like that. That's what we're going to first have. Now, how many times do you play this game on this problem? How many
10.
times? 10. It says find the fourth term, which the way we counted, the fourth term means you win 7 times. So I'm going to put a 7 for R. Now, if you're like, wait, how did you get that? That's because the first time, the first person is like if you win every single game. The next one's if you won 9, the next best situation. The next is win 8, then win 7. That's the fourth one. So I put a 7 there. So fourth term doesn't mean 4. Just so you know, it'll rarely ever be the same number, rarely. So 10 comma 7. The A is how many A's you have here. On this problem, I just have 1 A, so I'm going to put a 1 there. And my B is going to be a -1. Now, if we win 7 times, I need to put that power right there. We win 7. So if we're going to play 10 times and win 7 times, how many times did we lose?
3.
3, good. That right there is going to give us the solution in our calculator. So I'm going to go to Desmos now. So this is doing it without the triangle. And I know I went slower so far, but you'll actually be able to do this pretty fast as you go on. As long as you type a capital C, you can just type in NCR. You can also go to functions and then stats. And NCR is there in functions and stats as well. So what I was telling you is we'll always have 3 parentheses like that. The first one's going to have a comma in it. We had 10 for our N. So the first value tells the calculator what N is. Our R was 7. The A was 1. The B was -1. We said we were going to, again, A is odds of winning in the real world. We said we're going to win 7 times and we're going to lose 3 times. So my number is -120. This means I have -120. They're using the letter A here. A to the 7th power. Because I won 7 times. A to the 7th. And if A is 7, that means B is 3, because they have to add up to 10. That's my fourth term. That's A4 right there. So that's my answer. Now I'm going to show you this. Winning 7 times means you lose 3 times. You can set R to be the number of losses. The formula chart technically is that way, and you'll see that you still get the same solution. So even if you treat R as being your losses, you still get the same value right there. So either way, it'll mathematically be the same. Okay, so let's try another one together. It says, find the 5th term. So we need to write them out. You're playing the game 8 times. We want to find the 5th term. How many times does the first term win?
8.
8 times.
That's right. So since this is A, instead of using W, I'll use W for wins. We win all 8 times. How many times does the second person win?
7.
The third person?
6.
The fourth person?
5.
And the 5th person?
4.
Okay, and just since we were playing it 8 times, not only do they win 4, how many times will they lose? I know I didn't write this in the previous one. I'm just trying.
4.
4, that's right, because we're playing 8 times. So for you to get this solution, you would do NCR, you play 3 parentheses. You're always going to have that with a comma in the middle. That's what you'll always have. Then you'll plug in your values. The N, the first letter is how many times you play. That's an 8. The 5th term means we win 4, lose 4. You can choose either the wins or the losses. On this one, it's the same number, so it doesn't matter. So we chose a 4. Remember I told you rarely will these ever match? These aren't matching. So you can't just go off of that, put a 5 there. It won't work. You have 1A and negative 1B. 1A, negative 1B. And we said 4 wins, 4 losses. So you put that there. If you type that in the calculator, you should get the correct answer. Okay, 10 more seconds. Finish up, get your answers in. 3, 2, and 1. All right, time. I do have a majority on one of the answer choices here. They're circling in. However, I do have another answer choice that was chosen correctly quite a bit. So if you type this in the calculator, it should have spit out the right answer. Like it should have been exact. So if you just wrote what I did, it should give you the answer. By the way, this says coefficient. If it wanted the term, it would have on the answer choices a to the 4th, b to the 4th. Since they're both 4th powers, it would have a to the 4th, b to the 4th. Like whichever one's correct, if it was wanting the term, it would have this additionally. Whichever one was the correct answer. Now it would say, I'm going to change my instructions. If I had that on the answer choices, it would say not just find the coefficient, it would say find the 5th term. That's all it would say. If it said find the 5th term, that's what you would do right there, is you'd have the letters attached. Coefficient means just the number in front, which means this one, it said find the coefficient. My actual answer, I should have just said negative 120. That's what I should have done on this one. Okay, let's try one more. This one I call the Merry Christmas. What do you do when it says the x7y term? It doesn't seem like that makes a lot of sense, but that's actually giving you where we don't have any more work to do. Let me show you. If you're finding the coefficient with this, we're going to use the binomial theorem, which remember this is the skeleton that you're always going to have. Start there. And what we're going to do is we're going to type in our values. This right here is telling you your powers. That's going to be 7 wins, 1 loss. So I can tell you that goes right there. What number goes in the front right here?
Eight.
That's right, the number of times you play. This is going to be either the wins or the losses. It doesn't matter which one you choose. So what number goes here?
7.
We could do a 7 or we could do a 1. It'll give us the same answer either way. This is odds of winning. This is odds of losing. For this particular problem, it's a 3 and a -4. If we type this in the calculator, this will give us the right answer. NCR 8, 7, 3 raised to the 7th, -4 raised to the 1st. It's -69,984. So the x7y first term is -69,984 x to the 7th y. That's the x7y term. But they just asked for the coefficient. So the coefficient would be the -69,984. Did I get that number right, or was it 986? 984. Oh yeah, got it right. And I also want to show you, so we did wins there. You could have done losses, and you still get the same number. It doesn't matter which one you put in on the NCR portion. Okay, let me try you one more time, and then we'll go on to real world. This is the last one that's not real world. I want you to find the coefficient of this term. I'm going to let you go from scratch here for a little bit. All right, 10 more seconds here. And I'll call it time. It says find the coefficient of this term and the binomial expansion. So whenever we do this, we're going to write NCR with the first parenthesis with a comma, second parenthesis, third parenthesis. What did you put in the first blank?
6.
This is correct. You play the game 6 times. What number, someone other than Diamond, very good Diamond, what number do we put here?
2.
2 is fine. What's the other possible number you could put there?
-3.
Not a -3, but
4.
4. 4 is the other choice for right there. What goes inside this parenthesis?
2.
That is a 2. It's this 2. And what goes in this parenthesis?
-3.
That's correct. Now, these two are your powers. Just like that. And so that's what you should have typed in the calculator. By the way, if it was asking for the term and not the coefficient, like if it just said find the x squared y fourth term, then all of these would have x squared y to the fourth additionally at the end of the problem. So just telling you that so you kind of understand more the difference between the coefficient and the whole term. The term is everything with it. Okay, so now let's apply this to real world. Example 5 says, during a player's turn in a certain board game, a player must spin a spinner. There are 4 possible colors the spinner can land on. They're green, blue, red, and yellow. If the probability of all 4 colors is equal, what is the probability on landing on green 5 times out of 10 spins? So if you're not familiar, you have, like if you haven't seen a game show or something like that, they might have some type of spinner, and I'm gonna have a little arrow, it's pointing in. And on there are 4 different color sections on this spinner. So it labels them that one of them is red, one of them is blue, one of them is green, and one of them is yellow. So you come over and you spin this and you want to see what it lands on. If the probability of all 4 colors is equal, so I try to make it as equal as possible, what is the probability on landing on green 5 times out of 10 spins? So this is where you would use the probability. So I have 3 parentheses, NCR, followed by 3 parentheses. A little way to remember it, 3 letters, 3 parentheses. Comma goes in the first one. So according to this problem, how many times are we going to play this game? That's right. How many wins do we have?
5.
5, good. This is the odds of winning. What are the odds of winning?
One-fourth.
That's right, very good. The odds of winning this game are 1/4 because there's only one winning color and there's 3 losing colors. So 1 win out of 4, and over here it would be 3 losses out of 4 is the probability of losing. Now if we win this could be number wins or losses here. This in particular is the wins, and this one is the losses, the power. Whoops, I put that in a bad spot. I can't really fit in. Okay, if we win 5 times, how many times do we lose?
Five times.
Right, 5. If you win 5, you lose 5. It's playing 10 times. So those are our values that we plug into the calculator. This will give us the probability of landing on green 5 times out of 10. So we go to our calculator. We play this 10 times. We win 5 times. The probability was 1/4 for those 5 wins. We lost 3 times, or you lose 3 out of 4 times statistically. But we need this to happen only 5 times. That's the probability. It's about almost 6%. I'll take 4 decimals since the first one's a 0. So usually I only take 3, but since the first one's a 0, I'll take the next. So it'll be 0.0584. 0.0584 is going to be approximately the answer. 0.584. That's the probability of hitting green 5 out of 6. Whoops, 5 out of 10. Can't write. Sorry, let me try this again. Probability of landing 5 greens of 10 spins. A lot of times we express this as a percentage, so you'd say like 5.84% is how it will be expressed a lot of times. Now the next one, your DOL, I'm going to tell you how a student took this years ago for my class and what they did. So I'm going to first give you this one, 2 minutes to see if you can come up with your own answer, and then I'm going to tell you what a student did years ago, like about 6 years ago, maybe 7 years ago in my classroom. All right, as we finish up, I'm going to write down some of these decimals. I know this one off the top of my head. At least I think that's what that is. And I know this one, at least I think I do. I'm going to type these 2 into Desmos just to see what we get here. 45 divided by, was it 1024 maybe? 45 divided by 1024 is 0.0439, rounded, 0.0439. And this one, 15 over 128 is 0.117. I'm gonna make sure 1 over 40 is what I think it is. Yeah, and then 1 over 8. Yeah, okay. So there's your values that you should be comparing to. And so what you should have done is gone NCR, 3 parentheses. The first one has a comma. How many times did you win this game? Or how many times did you play the game? I'm sorry. How many plays?
10.
How many times do you win?
3.
3. Which if you win 3 times, how many times do you lose?
7.
Oh, what are the odds of getting a tails?
1/2.
Getting heads?
1/2.
There you go. If you type that in, you should have got one of those decimals. One of those will match. So about 6-7 years ago, I had a student who said, so wait, what does that mean, the actual odds of, like, say, winning all 10 times? And I'm about to show you on our old, or like the classroom calculator I have, it'll give it to you as a fraction what the answer is. And so basically what we were calculating is what are the odds of winning all 10 games? And I'll type it in on Desmos, but I think it's going to give us a fraction for that. I mean, a decimal. So the student was asking this: what are the odds of winning all 10 games? And he saw this is the odds of someone winning all 10 games. You see how small that is? Let me go show you in our school calculator. So when we were doing this years ago, we were in the classroom. It was back when we had only traditional classes. And so they typed in the same thing. NCR. On my old, or the classroom calculators, you don't have to do a capital C. On Desmos, you do. 1/2 to the power of 10 times 1/2. Whoops, not 1/2. 1/2 to the power of 0. And they typed this in, and they saw 1 over 1,024, and they were like, okay, so explain that to me. What does that mean? And that would mean for every 1 people who wins, you have 1,024 people lose. And so without saying anything else, he left that class and he went to lunch the next period. And later in that day, that's 3-4 hours later, he comes into my room with pulling out like just tons of $1 bills out of his pocket. I mean, I'm talking hundreds of $1 bills. And he told me he went around the cafeteria because he knew what the odds were. And he was telling students, hey, I have a quarter. Do you feel like you're pretty good at calling heads and tails? And they would say, yes. He said, I'll flip it 10 times. If you get it right all 10 times, I'll give you a $100 bill. And the reason he said 100 is because he had a $100 bill on him. And he was just waving around this Benjamin in front of everybody. And so people at lunch were like, wait, how do I play the game? And he was like, you put down $1. We'll flip this coin 10 times. If you can get it right all 10 times, I'll give you this $100 bill. And so he was going around the cafeteria playing this game, and students were paying $1 at a time to try to win $100. What he understood is that he could offer $100, but the odds were that 1,024 people would ever play before he would ever lose. So even if someone, Skyline's got almost 5,000 students. He went around the cafeteria. Even if he only went in his lunch, he's still working with over 1,000 students. Even if someone wins, you would have had another 1,000 losers. So yeah, he might have had to pay out his $100 bill, but he would have had about 1,000 $1 bills in his pocket at the same time. Does that make sense what he did?
Yes.
Okay, so that's how you use that in real world. What we've just been going through, that right there is how you use that in real world. And like I was saying, the odds are for every 1 winner, you would have 1,024 losers. That's what that means. 1 winner, 1,024 losers. And so he was charging $1 to play the game, and he was offering him a $100 prize, which means they were getting ripped off. He was the casino in that deal. He knew he was going to win, even if overall someone won. Now, as it turned out, no one actually had it 10 times in a row. After that, I started each year bringing a $100 bill to class at the start of this and saying, hey, if you can, I wasn't taking money for students because I can get fired for that. But I was just saying, hey, if you can flip 10 times in a row, and to make it faster, I just had 10 dimes out, or 10 pennies, or 10 quarters, whatever it was. I had them flip all at once. If you can guess the right amount, I'll give it to you. And one time I had one person won away. I almost had to give away $100. So I quit playing that game last year or 2 years ago, whenever it was. But that's how it works. Which, by the way, statistically, I have 150 students each year. It was probably about time for me to lose when you think about it that way. That I've been playing it for 6-7 years, 6 times 150 is 900. I was approaching that time when someone was going to win. All right, so we've seen the binomial theorem, we've seen that, and now the end of the lesson just asks us to expand. If things get a little bit crazier. And truthfully, this works the same. I'm just going to show you on your deal. There's a YouTube video if you want to watch this in detail. But for this one, I'll just work this one out with you. If we were going to expand this, let's do a little cheat. Let's see which one we can get the answer on. Nope. +3. Nope. Can't do it on that one. Hey, I think this. Nope. I'm wrong. Oh, yeah. This term. We can figure it out on this term right here. I'm gonna do the cheat to see which one of these is correct. You might be looking at it going, well, wait, there's 96s. One's positive, one's negative. And then the 24s, this says t squared, this says t. Okay, so how could this ever get more complex in mathematical, not gambling, but mathematical, is this, if they have a variable squared. So honestly, what this means, if you wrote out all the numbers, if you remember earlier for the row 4, I think they're 1, 4, 6, 4, 1. What we'd find out, and I'm going to write out the long ways using Pascal, so that's Pascal right there. Pascal's triangle. What you would have is 1 times 3t, whoops, this time you'd have a 1 times 3t, did it again, 3t squared on the inside raised to the 4th power. So 3t squared is the winner in this case. One person who wins every time. You would have 4 people who win 3 times and lose once. You would have 6 people who would win. Again, on this one, it's just weird, but just still think about this as being the winner. Who win twice, lose twice. You would have 4 that would win once, lose 3 times, and you would have 1 that would not win at all, that would only lose. And so for the sake of time, I'm just going to write the losing down. Okay, I'm going to compare it to this term to see which one of these solutions is correct. So this term is the 1, 2, 3, 4. It's the 4th. So not there, that's A1, that's A2, this is A3, this one right here is A4. This is the one I would use. So the number will be 4, 3 to the 1st times -2 to the 3rd. 4 times 3 to the 1st times -2 to the, whoops, to the 3rd. That's my number, -96. So that one has a coefficient of -96, which means my answer has to be A. The way the powers work, you multiply power to power. So it'd be t squared because you multiply those. U cubed. To use this one as an example, you would have 2 times 3, which is a 6. And that's why it should be a 6th, which could eliminate all of these are off. These powers on this last one are off. But that's how it works like that. Okay, so there's example 6. And if you had to use sigma, the way they would do this with sigma, this last thing, you won't, I don't want to assign these because I don't like them. Our calculators won't do this for us. If you're going to play 17 times, remember you move the n there. And I'm actually going to use the letter R just to make this more in line. And so the way this would work for sigma is you would do NCR. I'm going to change the color so you can see what's NCR. Are 3 parentheses with the comma in the middle. The n is always 17, but the number of wins counts up. And actually, when you do sigma, shoot, I forgot one more thing. You don't start at 1, you start at 0. And so this one would be 3x. This is a -5y. And this power is n minus r from the formula chart. N is 17, sorry. 17 minus r, and this one would be r. That's how you do sigma and the calculator, but it doesn't even work. So that's why I'm skipping this problem. And I didn't put it in the homework because it does not work, but that's how it would look. And their answer choices are just kind of strange. They do NCR a little bit different, but this is the only one where you start at 0. So that one's actually out. So you should start at 0. And this doesn't have an NCR, so it would be out. So on this one, the correct answer, I'm trying to see what's even, this is out. It doesn't have the -R, so it'd be C. That one's out on this one. Okay, this means NCR. It's another way of writing that. Our calculator doesn't know how to do it that way. So I just went fast through those because I didn't put that in the homework. But what I did do are these ACP problems. So we have about 10 minutes left in class. I'm going to let you work on number 1, and I'm going to stop this video, and let's see what you come up with. Actually, what I'm going to do is I'm going to help you out here. I'm going to do the 3 NCRs and the 3 parentheses. That's what I meant to say. I leave myself much space there. On this one, it says 4th term. So remember how you do that. If you have 8 wins, 8 wins is the first term, 7 wins is the second term, 6 wins is the third term, 5 wins is the 4th term. So that'll help you out there. This one, it gives it to you very precise. This one, it says 5th term again, and we play the game 12 times. So you'd have to think about it from 12. That's the 1st, 2nd, 3rd, 4th, and this would be 5th. And you can figure out how many losses you have if you play 12 times, how many losses you'd have to have on those 2. All right. On the first one here, what did you put in the front of NCR?
8.
8 is accurate. All right. What did you put in the second spot?
5.
Good. You could have also put 3 as 5 wins or 3 losses. What did you put in this spot?
3.
3. And this spot?
2.
Okay, that one needs to be a -2.
Oh yeah, -2. Forgot about that.
Yeah, and we have 5 wins, 3 losses that go there and there. So that would be your how you get the answer on this one. Okay, next one. What number do we put right here?
Ten.
10 is correct. And in the second spot? How many wins or losses do we have?
5.
5.
That would go there. I have 1x, -2y. 1, -2. And it's a 5 and a 5. So that would get you that one. And finally on this one, we have 12 on the front, and I'm getting 8 here. It could be 8, or you could do 4. 8 and 4. You have a 3 in the front and a -1 there because it's -1y. And so that would get you your answers there. So anyways, I enjoyed it. That's lesson 10.5. Make sure you get your answers put into PowerSchool Learning.